Axial force and axial deformation. How can we calculate them? Hello once again and welcome to the third lesson of material mechanics produced by lessonsforcivil.com. If you have watched our two previous lessons, you already know about the meaning of stress, strain and elastic modulus. We also talked about elastic and plastic deformations, right? In this video, I'm going to show you how to calculate the deformation caused by pure axial loading. So the first question is, what is pure axial loading? Well, let's explain it as simple as possible. Here I have a cubic member. If I draw the diagonals of cross sections, I can simply find the location of the center line. Now if I put a force exactly normal to the cross section and exactly at the center line like this loading is called pure axial loading, which means there is no bending moment and there is no shear force. In such cases, axial force is transferred through the member, and as you can see, the deformation is symmetrical with respect to the center line. But what if I put my arm at any given angle but 90 degrees? Well, as you can see in this case, the angles is going to change. Actually, this is mainly because my arm is inclined and not normal to the cross section. So actually, I'm applying a shear component. So this is not a pure axial loading condition. And there is another type of loading, which is when I put my finger normal to the cross section, but within a distance from the center line. As you can see, in such cases, one side of the object undergoes tension while the other side is under compression. And why such a thing happens? Well, this is mainly because when the load takes distance from the center line, it is also create a bending moment. And again, this is not a pure axial loading. Please bear in mind, all of the equations I will give you in this lesson are only acceptable under pure axial loading. Okay, so what does happen inside the material when the member is under axial loading? Well, in simple words, the axial force transfer alongside the material to reach the end, and there it is going to be counteracted by the reaction forces applied by the support. In this case, for example, my left hand is the end support. If you draw the free body diagram of any part of this object, you can simply find out alongside the member the amount of axial force remains the same. But what about the amount of axial stress? Is it always constant alongside the member? Well, definitely not. As you know, axial stress is equal to normal force divided by the cross-section area. So if the cross-section area is variable, like this object for example, the amount of axial stress is going to be different from one section to other. In this case, cross-sections are different and the same amount of axial force is going to create different amount of axial stress. And now here we go to the main part of this lesson, which is about how to calculate the amount of axial deformation. First, I explain it for a typical member with variable cross-section, and then I will simplify it for members with constant cross-sections. The general strategy we use to study a member with variable cross-section is to divide it into smaller parts, just like this. The main advantage of this method is that the amount of change in cross-section in any tiny part is quite negligible, so that we can assume the cross-section remains the same alongside each small part. So according to this formula, we can simply calculate the amount of axial deformation of each small part. And then by adding them together, we can estimate the overall deformation of the member under axial loading. This is the general formula to calculate the amount of axial deformation. Unfortunately, in civil engineering, most of the structural members we use are manufactured by constant cross-sections. So if I find a way to simplify this equation, it would be a very useful help for us. The second equation here is actually a simplified version, provided that the cross-section remains constant along the member. Well, I think it's time to practice a bit. Here is a question. We have two different objects that are under certain amount of axial loading. You have to calculate the amount of axial deformation for each object. And please don't be afraid to make mistakes. Write whatever you think. And remember, practicing alone is not useful unless somebody corrects you and identify your mistakes. And that is why we are ready to receive your answers and your questions on lessonsforcivil.com to help you learn more easily. So download the PDF version of this question and send us your answers and your feedbacks. Please share and like this video so that your friends can join us. If you subscribe our YouTube channel, you will automatically get noticed of every video we upload. Thank you for trusting us. I'll see you in the next lesson.